so for Unit 12, Day 3, we're going to be finding what are called determinants of a matrix and an inverse of a matrix, okay? So a determinant is just a single numerical value, which is used to calculate the inverse of a matrix, okay? Now, we're not going to be finding any of this stuff like inverses by hand or anything like that. The only thing that I'm going to maybe ask you to do is find the determinant of a 2x2 matrix by hand, because it's pretty easy. But once we get to a 3x3, it starts getting a lot more complicated here. So the determinant of a matrix is denoted by this symbol right here. So kind of looking like little absolute value bars of A, or you may see like determinant of A, something like that, okay? So the determinant is only defined for square matrices. So a matrix has to be 2x2, 3x3, 4x4, 5x5, so on, in order to be able to find the determinant, okay? So for a 2x2 matrix, to find the determinant, what we do is we use this formula. So if we have matrix A where it's A, B, C, D like that, then the determinant of A, we take A times D minus B times C, right? So we multiply the diagonals and then subtract. 3x3, more complicated, a lot more going on, okay? But again, we can do all of this in the calculator, right? So if we look at these guys right here for the dimensions anyway, let's find the dimensions. So A is 2 rows by 2 columns, so 2x2, right? B, same deal, 2x2. C, 3 rows, 3 columns, so 3x3. And then D is a 2 row by 3 column, so 2x3, okay? So let's put all these in the calculator. So second matrix, and then over to edit. A is 2x2, 1, -3, 2, 5. Matrix B is also 2x2, 3, 4, -2, 0. Edit for C. This one is 3x3, 1, 3, 5, 0, -2, 9, 7, -6. And then for D, edit. This one is 2x3. And -6. Okay, so quit out of there. Now, for these, right, I said you can find 2x2 by hand. So if we want to find the determinant of A, right, so the determinant of A, we would multiply this times this minus that times that. Right, so that would give us 5 minus -6. So 5 plus 6 gives us 11, right? So the determinant of A is 11. And again, we can find that in a calculator. So if we go second matrix, now what we want to do is we're going to do math with a matrix. So we're going to arrow over to math. And then that top option, the DET, is the determinant. So we pick that, and then we got to pick which matrix we want to do the determinant with. So second matrix A, if we did everything right, we should get 11, which we do. Okay? So again, this one's a 2x2, so we're good. If we check determinant of C, that one's 3x3. So remember, again, these have to be square in order to have determinants. So we're good there. So let's find the determinant. So second matrix over to math, determinant of, choose C. We get 235. for that determinant. Okay. If we look at D, this is a 2 by 3, right? Which they have to be square. That's not square. So there's not going to be a determinant, which again, if you check matrix D, your calculators, right? Determinant requires matrix 2 by 3 to be square. So it's, your calculator is going to say error, not going to be able to do it. So this one does not exist, okay? And if we check B, B is 2 by 2, which again, we could do by hand if we wanted to, or we go second matrix, math, determinant, second matrix B. Oops. Let's try that again. Second matrix, math, determinant, second matrix B. This one is 8. Okay? So that's how we can find determinants. Okay? So now we also, in order to find inverses here, the inverse of a matrix, we're going to use a graphing calculator. And just like when we did determinants, you can only find the inverse of a square matrix. Okay? So if it's not a square matrix, we can't do anything with it as far as inverse goes. So it says, if possible, find the inverse of each matrix. If inverse does not exist, right? D and E, convert any decimals to fractions for these matrices, all right? So the inverse of A. So same matrices is up top. A is 2 by 2. So that is square. We're good. So this thing has an inverse. So what we do is we go second matrix, A, and then right below that matrix button, that X to the negative first, that we're going to push that, and that's going to give us our inverse. Okay? So when we see whatever A inverse, right, we say that's the inverse of A, or A inverse, right? So that's what we're looking for. So when we hit enter here, it's going to give us this really ugly decimal looking thing. So what we can do is we want to convert that to fractions. We hit the math, and then that arrow frac is going to take that matrix and convert it into fractions for us. So we go 5 over 11, 3 over 11, negative 2 over 11, 1 over 11 would be the inverse of matrix A. Okay? So that's what we're working with there. B up top was also 2 by 2, so that's going to have an inverse. So let's find the inverse of B. So second matrix, B inverse. Again, math into a fraction. So we get 0, negative 1/2, 1/4, 3/8. Okay. C up top was a 3 by 3. So this is also going to have an inverse. So second matrix, C inverse. This one's going to be ugly. Turn it into fractions. Oh, I'm not sure why I didn't turn that into a fraction. So we've got negative 24 over 235, 38 over 235, 37 over 235, 63 over 235, and then we'll skip that for now. 9 over 235, 14 over 235, and negative 2 over 235. So this is something over 235. I'm not sure why this calculator is not changing that to a fraction. Let's see if we type this in. Negative 0.174468851. That'll go. Huh. Not sure why it's not changing that into a fraction, but that is something over 235. Your calculator should actually change that to a fraction for you, but not sure what's going on with that. Okay, but that should be a negative number over 235. Okay, and then for D, That's a 2 by 3, right? D was 2 by 3, yeah. So this one is not going to have an inverse. So even if, again, it's got to be square. So second matrix, D inverse, right? Matrix must be square. So this thing does not exist. Okay? So that's determinants and inverses, right? Again, graphing calculator, they all have to be square in order to have a determinant and an inverse. So try out that homework. Let us know if you have any questions.